All right, gentlemen, let's finish up naming these bicyclic compounds. The ones that we didn't get to in the handout from Wednesday, the September 29th lecture. So we want to name this one. All right, we need to start numbering from a bridgehead carbon. So I'm going to call this carbon 1. Remember, the bridgehead is the carbon that's attached to all the bridges. So here's a bridge, here's a bridge, and here's a bridge. Then I'm going to number around the longest ring first. So I need to see this is a 3-membered ring, 3-membered ring, and a 1-membered ring. Or sorry, 3-membered bridge, 3-carbon bridge down here, because this is a carbon on this corner. It might be hard to see that. And then a 1-carbon bridge on the top. So since these are both 3-carbon bridges on the bottom part, I can label this either direction. So I'm going to go this way. Okay, so I numbered around my longest bridges first, then I skip to my remaining bridge and call that carbon 9. Okay, so 9 carbons total. That means this is going to be something nonane. It's bicyclo, so remember in the brackets I need to say what are the sizes of all the bridges. So this is a 3-carbon bridge here. This is a 3-carbon bridge on this side, and then this is just a 1-carbon bridge at the top. So I would call that 3, 3, 1. Then I put the prefix bicyclo because I have these two ring systems together. Okay. Then I need to name the chloro part. So the chlorine is on carbon 9. I need to decide, is this endo or exo? So in this case, these are both 3-carbon bridges. So whether the chlorine is facing this way, right, closer to this side, or facing this way where it's closer to this side, either way, there's not a larger and a smaller bridge we have to determine endo versus exo. So this one doesn't need endo or exo in its name. This would just be 9-chloro-bicyclo-331 nonane. So let's do the same thing over here. One of these is going to be carbon 1. Okay, but remember I need to number this in such a way that I number along my largest bridge first. Okay, so even though this has the alkene, usually we try to keep the alkene number as low as we can. It's on a 2-carbon bridge, so I got to number around my 3-carbon bridge first. Okay, so then the question is, do I call this carbon 1 or this carbon 1? If I call this carbon 1, then I can make this carbon 2 with my substituents, and that'll keep my substituent numbers lower than if I did this as carbon 1, because then they'd be on carbon 3. So 1, 2, 3, 4. Then this bridgehead is 5. Then I got to decide, do I go up to this bridge or continue along this bottom, or go to this bottom bridge? This is 2 carbons, this is 1 carbon, so 6, 7, jump up and get that last one, 8. All right, now naming this, let's name it from the front this time. On carbon 2, I have 2 methyl groups, and because I have 2 methyl groups, I need to call this dimethyl something, right? And they're both on carbon 2. So 2, 2, dimethyl. Right, there's really no way for it to be endo or exo at that point because you have 2 groups on the same carbon. So 2,2-dimethyl, we don't need an endo-exo designation. It's a bicyclo again. Then I need my brackets with the rings. I need to adjust my stupid little dot camera that's falling apart. 2,2-dimethyl bicyclo, and then my bridge sizes is 3, 2-carbon bridge, and a 1-carbon bridge. So you always put these in descending order. 3, 2, 1. Oct, right? It's oct because there's 8 carbons. There's an alkene, so it's going to be oct something ene, and I need to name this based on the lower carbon that's part of that double bond. So oct 6 ene. Not the easiest thing to say, bit of a tongue twister. 2,2-dimethyl bicyclo 3,2,1 oct 6 ene. Okay, now let's do this next one. Okay, so let's give the name of this guy as well. I need to find my bridgehead carbons, so they're right here. In this case, because of the symmetry of the molecule, it doesn't really matter which one of these I make carbon 1. So I'll just pick this one as carbon 1. Also, it doesn't really matter which way around the ring I number because of the symmetry here. So 1, we'll call this 2, that makes this 3, and this 4, right? Because I have to, well, yeah, sorry. I have to include my bridgehead carbon, right? I have to make sure I keep this number as low as I possibly could because that's what we do with bridgeheads. So 1, 2, 3, 4, 5. For this particular molecule, because these are all one carbon bridges, it doesn't matter how you label this because we'll see that as long as you get this is carbon 1 and this is carbon 3, the 4, 5, and the 2 aren't going to come into play at all in the naming here. Okay, because they're all one carbon bridges, so it would be equivalent to number it this way, 1, 2, 3, or this way, 1, 2, 3, and then go either direction for 4 or 5. Right? If they had substituents on them, it would be a different story, but they don't. So I got a bromo on carbon 1 and carbon 3, so that's 1,3-dibromo. Then it's another bicyclic ring structure, so bicyclo, and my bridges are 1 carbon, 1 carbon, 1 carbon, so 1, 1, 1, and then 5 carbons total will be pentane. Okay, again, no endo or exo in this case because all the bridges are the same length. Okay, last one. This is exo-2-methyl. I'll pay attention to that more in a second. Bicyclo-2,2,1 heptane. All right, so I like to try to kind of generate in my mind my bridgehead carbons first. So here's my 2-carbon bridge. This must be my bridge heads then, or whatever's connected to this. So I said 2, 2, 1, so my bridge heads need another 2-carbon bridge. Okay, here's my other 2-carbon bridge. So 2, 2, and then a 1-carbon bridge, which would look like this. Okay, 2, 2, 1. And heptane, 1, 2, 3, 4, 5, 6, and this would be number 7. Okay, 2-methyl, but it's exo. So we got to remember, does exo mean it's closer to the smaller bridge or the larger bridge? Exo means it's closer to the smaller bridge because exo is a smaller word than endo. Easier way to remember that. Okay, exo is shorter, it's only 3 letters. So we got to be by the shorter bridge because we're exo. So I got to think about drawing these as tetrahedral. There's no line wedges or dashes in these types of structures, so this can be really difficult to visualize, and this can also be kind of difficult to build with a modeling kit. You could definitely do it though. Maybe I'll do it real quick. Let's go do it off camera. Okay, so I did it off camera. See if I can get it into the camera here. Here is my bicycloheptane. Can I even get a good perspective on this? So you can see I have the 1-carbon bridge coming straight up into the camera. And then I have my kind of cyclohexane looking structure underneath it. So 2-carbon bridge right here, 1-carbon bridge, and my other 2-carbon bridge. So if I want to look at the positions on carbon 2, the way that I'm about to draw this, okay, this is my carbon 2 with these 2 things. Maybe can I do it like this? Would this work? You see my Burger King King bobblehead. Super Bowl 51 bobblehead, the Colts, Peyton Manning. That's what I'm talking about. Okay. Anyway, that wasn't. Didn't mean to show a cameo of this, but let's continue talking about this. If I look at the endo versus the exo positions, here, the green and the blue. Okay, and we try to look at which one is closer to which ring. You can see how when I draw it with the blue or the blue position, that would be my exo position because that's kind of pointing up towards this short 1-carbon bridge. When I have it in the green position, that would be my endo, where I'm actually closer to this, closer to the other 2-carbon bridge, right? It's pointing down, which the 2-carbon bridge is also pointing down. The blue one is pointing more up towards where this 1-carbon bridge is. Okay, so hopefully that's helpful. If that demonstration of my model wasn't helpful, then model it yourself and look at it. Okay, use your modeling kit. But anyway, so this is tetrahedral. I need to just draw this as being sort of up towards that 1-carbon bridge. So this would be my exo methyl group. And then this H, right, is kind of pointing more down. If you looked at if you build the model, you'll see how basically what I'm looking at is sort of like a pseudo equatorial position for exo and a pseudo axial position for endo for this particular molecule. It's not explicitly axial equatorial because we're not in the chair conformation. We're in this weird bicyclonone heptane conformation. Okay, so hopefully that helps a little bit on this naming stuff, because I know this isn't in the book. So you can go over these, you can practice these again and try to see if you can come up with those names. Okay, but we do need to know these. We'll see these again later when we do Diels-Alder reactions in the future. So a little something exciting to look forward to. Okay, that's all I got. Goodbye.